9.2 Vector components. Each vector at an angle can be described as a combination of two perpendicular vectors. We call these its vector components. The horizontal component, the one that goes along the x-axis, is called the x-component. The vertical component will go along the y-axis, so it's called the y-component. We're going to start with an example because finding the vector components is often easier to see through examples. The vector we're going to look at is 30 meters at an angle of 40 degrees north of east. Drawn out, it looks like this. The x-component is horizontal, and the y-component is vertical, and we make sure that the x and the y are perpendicular to each other. To find out the value of x and y, we use our trigonometry, starting with SOHCAHTOA, where h refers to the hypotenuse, the y-component in this case is opposite to the 40, and the x-component is adjacent to the 40-degree angle. Since sine theta is equal to opposite over hypotenuse, that's what SO tells us in SOHCAHTOA, the opposite can be written as h times sine theta. In this case, the opposite is y, the h is the 30, and theta is 40. Y is 30 times sine 40, which gives us 19 meters to the north. Cos theta is adjacent over hypotenuse, which is what Ka tells us in SOHCAHTOA. The adjacent equals h times cos of the angle. So x equals 30 times cos of 40, which is 23 meters to the east. Here's a general method you can use to find the perpendicular components of any vector. To find the perpendicular vector components, we start by looking at the vector as it's written. The vector is equal to its magnitude at an angle theta blank of blank in the of statement. The first direction listed in the of statement is going to be given the sine function, and the second direction will always be using the cos function. So it could be written sine of cos. The vector in the x direction will be the magnitude of the vector times sine or cos. It depends on which one is most appropriate to use of the angle. And the vector in the y direction is found by multiplying the magnitude times the appropriate trig function, sine or cos, of the angle. Let's look at another example so you can see how this works. Here's a displacement equals 100 meters at an angle of 25 degrees east of south. The east is an x-component because east runs along the x-axis, and the south is a y-component. The first direction listed is sine, the second direction listed is cos. That tells us that the x-component will use sine. So displacement in the x direction will be 100 times sine 25, which is 42 meters to the east. The displacement in the y direction will use cos. This is 100 cos 25, which is 91 meters, to the south.